A video? Did you put that live?
Hold on, buddy. We're live right now, okay? But it's not. I just want to make sure it's broadcasting. I'm not on the right channel here. I'm going to say, excuse me, please.
Excuse me?
I'm going to say, excuse me, please.
Excuse me?
All right. Can everybody hear me? Am I live? I'm going to say, excuse me, please.
Excuse me?
Awesome. Thank you so much. I was having a little difficulty this morning here, so I wanted to make sure it's working. Awesome. So everybody, good morning. Again, I am Michael, and this is
Robert,
and we're back here today to share another exciting activity with you in the realm of circuitry and magnetism, and we're going to look at a little bit of that today. And hopefully by the end of today, we're going to build a speaker, and we're going to be able to play some music from that speaker. But before that we do that, I want to talk a little bit about some physics and some science. Robert, do you know what the term goat means? When you hear goat, what does that mean?
I forgot what OUT means, but I remember what G means.
What does
Greatest.
The greatest of
All time.
The greatest of all time. So often you hear that in reference to sports players, right? Like if I say, who's the greatest of all time in basketball, what would you say?
Michael Jordan.
Michael Jordan. And some people would argue that maybe it's even Kobe Bryant or LeBron James, right? So when we talk about physics, we have some greatest of all times that we talk about. Can you name one of the greatest of all time physicists? Can you think of any? I know you always try to forget their names, huh?
Albert Einstein.
Okay, that's a good one, Albert Einstein. And what's another good one? Isaac
Newton.
Isaac Newton. So when people hear about the greatest physicists of all time, they often think about Albert Einstein or Isaac Newton, but they leave one very important physicist out, and that's one that we're going to talk about today. And his name is Michael Faraday. Okay? And what Michael Faraday is important for is he did a lot of work with magnets and magnetism, as well as electricity, okay? So one of the reasons why we're able to live stream today and we have all this wonderful technology around us is because of a physicist named Michael Faraday. Without Michael Faraday, this computer screen, this camera, this microphone, this cell phone would never have been alive.
And my cell phone right there.
And of course your cell phone there. We can't forget your cell phone, huh?
That's charging.
That's charging, and we're going to use that cell phone later, huh?
Because I use it all the time.
So real quick, I'm going to switch my screen over here, and we're going to take a look at a bar magnet. Okay? And in a bar magnet is really cool because it has a magnet, just like these magnets that we have in front of us.
No, they're not.
Huh?
They're really heavy.
Yeah, they're heavy, right?
But these are easy.
Those are easy? Those bar magnets are heavy?
Mm-mm.
So look at the magnet rubber on the screen. You see how it has two sides, right?
Mm-hmm.
An S side and an N side. The S stands for the south pole of the magnet, and that's the north pole of the magnet. And what do you think all these little lines are around here that you see?
Like where it's going for south and north?
Yeah, so it's going south and north, and it's showing, these little lines are showing the magnetic field. Because a magnet is cool in that it doesn't actually have to touch something to be able to control it, right? So if I put a compass, a little compass up here, notice that if I move the magnetic field, those are those little lines here, it's going to move around and control that, right?
Look.
Yeah, so you're doing that right here with your real magnets, right? So you can see that these magnetic field lines can control things. So even if you have these all the way over here, like you put them over here, you don't actually have to touch it, right? Here you go. You could try it. You don't actually have to touch it. You just put it close enough and it can control it. It brings it to it, right? What happens if you were to have two magnets? Let me see these. What if you were to have two magnets and you put them like that? What would they do to each other?
Make a bubble inside.
Okay, so they're pushing against each other, right? Those are these magnetic fields. Yeah. So if you have two magnetic fields next to each other, they can attract each other or they could push away from each other.
Oh, I get it. It's
get
because
it?
that one's red and that one's white.
Uh-huh. And opposites attract. Like sides repel. So the north doesn't like the north and the south doesn't like the south. And that's why they push against each other. Now, that's not what Michael Faraday found out. Michael Faraday actually knew that since a little kid. They've known about magnets for a very, very long time. But what Michael Faraday discovered, that was that circuit, like we hooked up last time, we hooked up a light bulb, right? And you remember it made a loop? And let's see if I could change.
Look what he got on him.
Yeah, it attracted the tool too.
Okay, what else
So
did
Robert,
he attract?
let's look at the screen real quick, okay? And then we're going to come back to attracting these magnets in a minute. Okay?
He would attract to that.
You think it'll attract to that? What, this?
No, the battery.
Oh, the battery? Let's see. Is it attracted to that? Yeah, it attracted it. Okay, so Robert, we're going to make a magnet in a minute. It's going to be really cool, okay? Let's look at the screen here. So you remember you hooked up a light bulb like that last time, right? And the light bulb turned on because you had a battery hooked up to it. Mm-hmm. Do we have a battery hooked up to it right now? Mm-mm. No. So what Michael Faraday discovered is that if you have a magnet like this one, and you were to move it inside a coil, you could actually make the electrons inside the wire move.
Oh, I'll come back.
Where are you
with
going?
One
with one what?
Of those.
Wait, one what?
That.
The magnet?
Mm-hmm.
You have a magnet?
Yeah.
Okay, go get it real quick. So while Robert goes gets a magnet that he wants to bring to us, we can move a magnetic field in and out of a wire. And what Michael Faraday discovered is that that magnetic field, and I could pull up that field for you. As that field moves in and out of a wire, it is going to induce motion or energy to those electrons. Anytime you have electrons moving, you can generate electricity. So something cool that Michael Faraday discovered, and he was one of the first people to do this, is that magnetism can generate electricity. So if you have a moving magnetic field near a wire, you will generate electricity. He also discovered that the opposite of that works as well. So if you have a simple battery hooked up to a wire and the electrons are moving through, if you had a compass near it, I already have the compass up here, you can see that it's generating a magnetic field by moving around the compass. So you can actually tell that a wire with electrons moving through it generates a small magnetic field. If you were to have more loops...
Okay, I couldn't find it, but I bring this to make one.
What's that? Oh, because it has a magnet on the end there, right?
Mm-hmm.
Awesome. So you're right. Those have little magnets in there. So Robert, what I was just telling everybody is here, when we have a magnet, if you're moving the magnetic field, you can make the electrons in the wire move. So in these wires, there are actually electrons already in here because of the metal. And when you move the magnetic field, those electrons are going to move too. You can't see them, but they move, and you can see them when they show off energy through light. Okay? Now the opposite is true too. Look at this. And we're going to make one of these right now. If you have a battery hooked up to a roll of wires, we call that a coil, you can actually create a magnetic field, a magnet. Are you ready to try that? Awesome. So Robert and I are going to try to create a magnet right now, an electromagnet, by taking electricity and generating a magnetic field from that electricity. So let me go back to our work surface here for a minute. And Robert brought these toys here. They have little magnets in them as well, right? So maybe when we create our electromagnet, we could see if we could push or pull these with our magnetic field. Okay, so Michael Faraday said, if we take a wire, let's use this wire right here. This wire you could buy anywhere in the stores. I was about to say Radio Shack. I don't even know if that exists anymore. But you could buy these on Amazon. When you're making electromagnets or coils, it's always better to have a thinner wire, so that way you could get more and more coils. So this right here is a 22 gauge. 22, I don't know if you'll be able to see that. There you go, 22 gauge. The larger the gauge number, the thinner the wire. So it's opposite. All right. So we need to make a coil. But do you have any ideas of how we can make a coil? What do you think?
I'll get the materials.
Okay, well, I have wire here. And we need to wrap the wire around something over and over again, right? So let's get out a lot of wire here. And let's start wrapping.
And a lot of magnets. Okay, magnet.
Well, we don't need a magnet right now because we're going to make a magnet. So I'm actually going to use this battery. I think this battery is good because I'm going to need a battery anyways to make an electromagnet. So what I'm going to do is I'm going to wrap this coil around and around and around and around and around and around a bunch of times. And before I do this, just so we're not confused at all, I want to show you that this battery alone is not magnetic. So, Robert, where are those paper clips we had? Here's a screw from our project the other day. I take the battery, it doesn't pick it up, nothing happens to it. I have a couple paper clips here. If I try to pick up the paper clips.
You see the special one?
Yeah, that one's open. You can put that down here too.
Yeah.
We can see that nothing picks up, right, Robert? So let's go ahead and make our coil now. I'm making the coil by wrapping the wire over and over and over again around the battery. Now this could take a long time, depending on how fast you're wrapping. You could push them together, squeeze them together, so you could have a nice, really tight coil. Some more wire out here. Right. Wrap, 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 wrap. This could get really tedious. And your hand gets tired of holding the coil, but all right. Okay. Now once you have all this coil together, we're going to cut the other side off. So we have two sides sticking out. And then the next thing you have to do is you have to remember that wires always have a protective cover on them. So when you have a thicker wire, like these wires here, it's a big, thick rubber insulation. However, when you get wires that are really thin, like this magnetic wire here, and it's called magnetic wire just because it's thin wire, you have a enamel, a coating on there that you have to take off. Now you could just scratch it off maybe with a key or a file or a sharp edge. I like to use sandpaper, so that's why I have this sandpaper here. Now I'm gonna move this close to the camera I've already done one side, so I think you may be able to see that on camera. Let's go ahead and check that out. And you guys get a nice picture of my head there too. Can you see the difference in the color? So here it's like a reddish color, and then that's a copper color. Yeah, Robert, I have no hair, okay? Everybody knows this already. Okay, so Robert, we need to, let's see what I want to do. Can you scrape this off here? Okay, you gotta squeeze that sandpaper. Squeeze it like that around the wire, and now he's gonna pull, okay? Watch your finger though, don't put your finger inside, on the outside, there you go. And then pull it over and over again. And what I'm doing again is just taking the enamel.
Why are you taking it off?
Off, so that way we could have a wire. Do you see the copper wire, the color change? We want that copper wire exposed. So that way, we can touch it to either side and see if our magnet works. Oh, look at that, Robert. We picked up the metal with it. Look.
Wait.
Now I don't want to let go because I'm holding the wires there to make the magnet, okay? If I release it, it falls off because it's no longer magnetic. So this is a way that you can make a simple magnet at home. Like it's picking everything up. Oh, fell off. Now, if you're doing this at home, just be careful that if you hold the wires onto the battery for long enough, you're actually creating a short circuit because there's not a lot of resistance in this coil. So you're going to notice that the battery gets really warm on your fingers, okay? And even if you left it there for very long, it could potentially start a fire, okay? So please just notice how I didn't tape it down or anything. I just used my fingers to hold it. That way, when I know it's getting too hot, it's time to let go. There you go, a simple magnet, bud. There you go, you could have that. All right, remember you just got to, be careful, it unwraps. So, if we go back here, that is what Michael Faraday discovered, that when you have electricity flowing through a wire, you can generate a magnetic field. And now one reason why you have coils is because, okay, let go of it then. There you go, perfect. You have coils because the more wires you have, the more electrons you have moving in similar directions, and you can actually create a magnetic field. So how is this useful besides making a little toy magnet? Well, if you have one magnet, like this one right here, this is called a transformer, and you move it near another set of coils with no electrons moving, what do you think is going to happen if I put it inside?
Gonna turn on.
Let's see if you're right. It's inside. It's not turning on.
I'll put it a little bit out.
Okay, I'll put it a little bit out.
No, back in a little bit. No.
Do you notice something that's happening, Robert? When does it turn on?
Oh, I know. When it touches the Y on it.
Okay, but maybe it's just touching because that's kind of big, right? But notice what happens. Look what's happening to the battery and the coil when the light turns on. What is it doing? What is the battery doing when the light turns on?
It's moving.
Awesome. So that's what made Michael Faraday the greatest of all time.
The goat?
The goat.
He's a goat.
He's a goat. He was able to discover that when you have a magnetic field, the magnetic field has to be moving in order to induce current or make the electrons move. If the magnetic field is stationary and constant, it will not create electricity or generate electricity is a better word. So what we should do is we have to have a changing magnetic field. But if you have a linear system like this, you don't want a magnetic field that you have to keep moving in and out like this. My animation's a little slow, I think, but okay. You don't want to have a magnetic field that you have to keep moving like this and over again. So what Michael Faraday created is the first electric motor. So he discovered that if you have a changing magnetic field, where the magnetic field is continually changing, then you can generate constant electricity. It looks like a ship, huh? But it's actually called a water wheel.
Water wheel.
And in the old days,
they used to use wheels like at the water backyard where you twist and then twist and the water comes out.
Not like that. I'm talking about in the old days, in the cowboy days, where they used to have the water from the river and it would turn a wheel, and that's how they used to have their machines run, right? So I almost said Isaac Newton. Michael Faraday discovered that if you have a wheel turning with water like they used to have in the old days, and you attach a magnet to it, you can make that magnet turn over and over and over again. And as long as that magnet is turning, you can generate electricity. Do you see that? So the faster that magnet turns, the more current you're going to have. So you're going to be able to produce more electricity.
Make it more faster.
That's as fast as it goes, but for this demo. But can we make the... Let's see if we can make
the pirates driving the ship really fast.
Yeah. And look, we could add loops, and the more loops you get, the stronger the magnetic fields are between the two.
Why is it going bing? Are they having a party?
They're having a party, electricity party. So Robert, you have all this electricity and technology, and you like watching TV and playing video games, and you like being a celebrity on Twitch, right? All this is possible because of a scientist named Michael Faraday. And he's right up there with the great Isaac Newton and the great Albert Einstein. If we did not have Michael Faraday teach us this idea of magnetic induction,
video games.
No video games, no cameras,
no TV.
Well, no digital cameras, no TVs. These light bulbs here wouldn't even be on because we need electricity. Now, there is a very famous dam that was built in the U.S. that uses this technology, and it generates a lot of electricity for the West Coast.
Beaver Dam, Beaver.
Not the Beaver Dam, it's called the Hoover Dam. The Hoover Dam.
I'm a beaver. I built a dam.
So,
water can go.
Okay, Robert, sit down, please. You're in the way. Awesome. So, Robert, I have a speaker here now. And now that we learned about magnetic flux and induction by Michael Faraday, we could actually try to put this technology to good use. All right? So right here, I have a speaker that was bought from the store. Okay, just a normal speaker. If you hooked up wires here, you'd be able to play music from it. But what I decided to do...
You seen that on the table?
You saw it on the table a couple days ago?
Take this off and then put it back on.
Okay, well, let's do that. I want you to take that off right now, because Daddy actually cut it open for you, so that way we could look inside. But as you open it, be very careful, because there's still 2 wires hanging, okay? And can you see it on the camera? Good. Everybody can see what you're doing there. It's hard to pull off, right? You want me to help you out?
And it looks weird inside.
Yeah, it looks weird inside. All right, we have it opened up. So what we're looking at is the inside of a speaker right now. Huh. If you're having issues watching the video, it may be because of your Java configurations aren't updated. So maybe it's an update on your computer that won't allow it to work. I got all these simulations from a website called PHET, P-H-E-T. And they have educational simulations in science and math that help teach concepts like we're learning today about induction. All right, bud. So what do you see inside this magnet? Sorry, I said magnet. What do you see inside of this speaker?
A little capsule to put this in.
Okay, but look inside here. What do you see? Notice what you see inside there. What do you see?
Like a little button.
Okay, that looks like a little button. What do you think that little button is? Why don't you discover? Bring something metal near it and see if you can figure out what it is.
A magnet.
It's a magnet. So the back end of a
Ow!
speaker is just a giant magnet. That's all that is inside that speaker, is a magnet.
Magnet.
And what do you see on this side? What is this right here, Robert? What is this? Did that look like something else we just made? It's not magnetic. Good experiment. So you put the screw there, right? So the screw doesn't attach to here, so it's not magnetic. But if we touch here, that is magnetic. Huh.
Can I join your party? Oh, I'm not magnetic.
You're not magnetic either.
I really can't go to any party. Wait.
So Robert, what does this look like we just made here? What does this look like that we made? I'm gonna give you a hint. I'm pointing at it. Right here. What is this?
A magnet?
Oh, well, we made a magnet out of a coil. So right here, there's
a coil.
Awesome. Give me 5. You got it.
Okay, can I give you 5 again? 5.
Oh, 5 with your head. Okay.
5, but...
No. All right, let's look here. So we have a magnet and we have a coil. What do you think this coil is going to do when it gets near that magnet?
Ooh, hot up.
Okay. Maybe if we have electricity going through it, it's going to move, right? So a speaker works just by having 2 magnetic fields near each other. You have the magnet. Let me use something non-magnetic. You have a permanent magnet inside that always has a magnetic field. If you bring metal near it, it'll attract things.
I'll use something non-magnetic.
And then on the other side, you have what's called a temporary magnet. And I hope you all can see this here. Let me see if I can get that closer on camera. There's a coil, Robert. Some people can see, okay? There's a coil here, and that coil is not magnetic right now. However, if we listen to what Michael Faraday showed us, and we push electrons through here, like with a battery or an electronic device, we can turn this into a magnet as well. So a speaker just works by having 2 magnetic fields interact with each other and push back and forth at the beat of the music. Okay, so what we're going to do for the remaining of our time is we're actually going to build our own speaker. Again, all you need is material to hold things together. You need a magnet, some sort of magnet, and you need what they call magnetic wire, which is just really thin copper wire. So I have this wire here that I used for our coil earlier, but notice how big it is, right? It's not small enough for my application. So I actually used a a higher gauge wire, which gives a really thin wire. It's so thin, don't think you can really see it on camera. This is actually a 32 or 34 gauge. It's a 34 gauge.
It's so thin.
It is so thin. So we're going to actually build a speaker right now. I brought some materials here. These materials I got from the 2-Bit Circuits Foundation warehouse, and they're just recycled goods. Now you could use any material to do this. You don't need this cardboard tube. One material that you could use, that I know all of you have at your house because I can't find any in the stores, is toilet paper. You can use toilet paper rolls to make the basket or the container to house a speaker. You could even make little thin ones that you could put on your ears and make them into headphones.
A can.
So awesome. Let's take this can apart right now, bud.
Wait.
What we're going to do is we're going to actually start assembling our speaker. So I'm going to put our hot glue gun.
Okay.
Not yet. We got to let it get hot. I'm going to let that warm up. And I already have a design for the speaker that I like. I made a couple of these before. And so hopefully it works this time. But this design is really simple and I like it a lot. What I'm going to do is I'm going to attach this lid. It's just a lid from maybe like a cream container. I'm going to glue that to the bottom of our cardboard roll. And by doing that,
and
I am
on the top.
In a second. By doing that, I now have my basket, so my container. And that's going to be like this piece of metal right here. And then inside that basket, I will be attaching my magnet. On the top, I will have a material. This is the material I'm going to use for the top. And so I have to attach a coil to this portion right here. Once I have it all assembled with all the electronic components in there, we could attach it to a phone, and if it works, we have music. All right, so I'm just waiting here for my hot glue gun to get a little bit hotter. In the meantime, while that is working, I'm going to use this straw, this plastic straw here. Again, I took this from one of Robert's baby bottles that he used to have, his sippy cups. And I'm going to use that just to elevate. I'm going to glue that inside, and that's going to elevate my magnet to the top portion of where I'm going to put this with the coil. All right, so let's see. You can use a ruler if you want and get exact measurements, but I'm just going to, estimate here. So I'm going to make the straw about that big. Gotta cut. See if my hot glue gun's hot yet. Almost.
Made my container.
Unfortunately, I don't have enough toilet paper to make a fort. Enough toilet paper rolls. I would do that if I had some. That'd be fun, huh? Would you want to make a fort out of toilet paper rolls? Yeah, and then you can play your game Fortnite, right? Okay, Robert, are you going to want to make one with us? Can you try to find it?
Can you make it my style?
You can make it your style, of course. This is Daddy's style, but like I said before, you don't need these exact materials. You can find whatever materials you want to try to make your own speaker. So while I'm doing this presentation here, why don't you go to Dad's office and you can rummage through all his materials from 2-Bit Circus Foundation and select more materials you want. And I like your selection here. You have some caps like I do. You have a nice wood stick. I wonder what he's going to use for that.
I have 2 silver caps.
Nice. We'll find out when he comes back. All right. Let's see if our hot glue gun is warm yet. Taking forever to heat up here. So while my hot glue gun is heating up, where is this project applicable? This project is applicable in any physics class, 8th grade. You could even do it with elementary students. I used to do this in high school with my seniors and my juniors when we were studying energy and electromagnetism. Now, if you go to the 2-Bit Circus Foundation website in our playbooks, you can find lessons, full lesson plans that give pretty much 2 weeks to a month long sequence of activities you could do to study electromagnetism. And this is the final culminating project where I have students construct the speaker or headphones, and then they have to tell me how it works. They draw pictures and explain all the science behind.
I drew pictures in my head.
You did? All right, I'm looking forward to see what you're building over there. Hot glue gun is taking forever. I think it's getting there. There we go. All right, so now I'm just gonna start putting glue. No.
My feet huge for.
There we are. So I'm going to start putting glue on the bottom here of the tube.
I need a big whole piece of stuff.
Big whole thing of Ford that you're going to make there, right?
Look how big it's going to be.
Yeah. I'm rushing this hot glue gun. It's barely heating up yet. And then the glue is going to dry by the time I stick it. We'll see. Awesome. I think it'll stick there. Nope. Get a little bit more glue on there. Sorry, I can't see what I'm doing here.
Don't. I wonder how I'm gonna do it. Keep falling apart. I don't have any hot glue.
I thought you were making a speaker.
No.
Now you're making a fort. You need TP rolls for that to help out, huh? Awesome.
Okay, it's getting better.
Okay, so with that done, now I'm gonna take
look,
my.
It's better.
Awesome. I'm gonna take my plastic straw here. I'm going to glue this as well to the bottom. Put a lot of glue on there to make sure it sticks. Hope you guys can see in there. Now I'm gonna try my best to get that centered. It doesn't have to be perfect, but the closer, the more efficient your speaker will run. Okay, that looks good. Now, magnets. Now, the best kind of magnets for this are going to be neodymium magnets.
Is it destroyed? Can you scoop? I don't want it to get destroyed.
Right, it won't be destroyed, okay? Now, let me finish this up, okay? So you take neodymium magnets. I like to grab a bunch. It'll work with one, but again, the stronger the magnetic field is, the better off it will be.
Please don't get destroyed.
So I am going to add some glue here. Glue my magnets into place. Okay. And I'm going to take this off and re-glue it at the bottom just because the glue didn't stick well.
Almost done with my fort.
All right.
I just need 2 more pieces of those cones, and then I'm done.
So as you can see here, I've attached the bottom. I have a set of magnets glued to a stick, a straw, and a basket to hold my speaker. All that I have left here to try to do is to make the top part, the cone, with the coil, and that's the part that's going to vibrate back and forth to make our sound for us. All right?
Yeah, I'm gonna beat you.
Okay, you're gonna beat me? You're gonna go that faster than me?
Yeah.
All right, we'll see. We'll see who can make this faster. Okay. Now, I need to make my coil. So I have to have something small enough to wrap this wire around, but something large enough that it'll be able to fit over the magnets. So, luckily the battery is a little bit bigger. So I think that's a good size again to wrap around. If you don't have batteries to do this, you could use something like a marker, a stick, a screwdriver handle, anything round. Leave a little bit of additional string off of the end as you start your coil because you're going to need that later to tie to a wire to be able to play music. There we go. Let's move some stuff out of the way. So I'm going to just start, again, the tedious process of wrapping the wire over and over again. Now, again, this wire is really thin, so it's harder to work with as far as your hand moving around. Keeps coming unwrapped here. Another strategy, if you don't want to use your hand to wrap around, is you can fix the spool, and then you could just twist like this. But I don't want to tie it to the battery, tape it to the battery. So I'm just going to use my hand like this, and let's hope it doesn't give me too much of a challenge. Now, out of building the entire speaker, this is probably the most tedious and longest part, is wrapping your coils. Now, remember from the exercise we did earlier, the more windings you have, the stronger the magnetic field will be.
I'm done.
Awesome, buddy. I like it a lot. That's a nice fort. We will show everybody your fort as soon as we're done with the speaker before we leave.
Hey, it shows a couple.
Yeah, you can see a couple of them, but a lot of it's off. Okay. So just keep wrapping around, wrapping around, wrapping around. Again, the more windings, hopefully the stronger the magnetic field will be. If you get a couple of the windings crossed, it's not the end of the world, but try to keep them as straight as you can. Another thing that I just remembered is as you're wrapping it, you kind of want to wrap it tight so that way you don't get them all mixed up. But you don't want to wrap them too tight because then you won't be able to slide it off of the battery or whatever cylindrical object you're using to wind. Speed it up here a little bit. All right. Let's see if our coil works well now. Use some scissors to cut the other end off. Now, a trick that I like to use is because I already have the hot glue here, is I'm going to gently slide it off the battery. Sorry, you couldn't see again. Slide it off the battery. So you see I have a nice coil here. Okay. And I'm going to use just a little bit of hot glue to kind of hold that wire and that coil together. Now you could use hot glue to do that. You could use tape. A bunch of different materials you could use. Anything you have that's light weight. You don't want it to be too heavy. I just smear that together to hold my coil together. It's not the neatest in the world, but I think it will do for our purposes. Again, you want to leave 2 wires, one from each end, hanging out, because that's what you're going to be attaching to your audio device, like your phone. Okay. Now we need to attach the coil somehow to the vibration box, the cone. Hot glue will do the purpose again. Awesome. So here I have a cone. The cone is the part right here, the disc that's going to vibrate. It's clear because I wanted you to be able to see the inside of the speaker as I make this. You can set this over the magnetic field. Okay. You don't want to glue the magnet to the coil because then you will not have the ability to allow the cone to vibrate and move back and forth. Now you can kind of see as I put it on here, it's not staying on there, right? It's tipping. So I thought of an idea to hold the edges up to make the speaker. And something I had laying around the house that I thought would be really cool was Q-tips. So I just cut Q-tips at the edge, and I made little holes in here just by poking really hard with the screwdriver. If you have a drill handy, I have one, but I didn't want to use one to show it could be done without it. And then you just poke those in there. See what I want to use to cut this with. Okay, so I pre-made 2 holes already. The other 2 holes I'll make right now. And what that's going to allow me to do is hold the cone above the magnets, and hopefully we'll be able to produce sound from that. So I'm going to go ahead and make 2 more holes here. Let's see here. Oops. Again, if you have a drill, this is probably easier to do with a drill and a lot quicker and neater and safer. But it can be done without a drill for this particular material. And again, your design, if you decide to make one, does not have to look anything like mine. It just has to keep the engineering principles in mind. So you want to be able to have that magnetic field and a coil. Okay, let's see, screw. It's attached to my magnet. Now, I just poked them in there, and they seem to be holding pretty well. But if they're falling out, just a little bit of glue at the end there, put it back in, and then it should be off and running. Oh, that one just shot too far. Right. Okay, got one more to go here. Oh, that one doesn't want to stay in too well. Smaller. I'm just cutting these Q-tips a little bit smaller so that way they could be just about even. So the top cone will lay flush. This one I'll put a little bit of glue on to make sure it holds. Awesome. Have my top part right here. Let's see if it sits there. Oh, that one fell off. Okay, so I'm going to glue this one in as well. And again, if it doesn't work the first time, just go back and change your design up. That is part of the engineering design process. You might not get it right the first time. You might not get it right the 20th time. Got to keep going at it until it works. Try different ideas here. I want to make sure I have the right polarity here. Okay. Oh, now it's too high. My magnets were too high here, so let's lower that again. This doesn't want to stay glued. May, can you tell them not to come back here so that's not too loud? Sorry if you guys hear a lot of background noise. My gardener showed up again today, so you might hear their lawnmower and stuff going. Awesome. All right, it's not the neatest, but I think it's going to work. One thing I mentioned before when we did the other coil, but I want to re-mention here again, is remember that there is an enamel coating on the end of the wires. So you have to remove that coating to expose the copper underneath it before you actually attach it to get a good connection. Now, when you have wire that's really thin like this, please make sure that you're careful stripping the coating off, because the wire is so thin that if you pull too hard, you will actually keep ripping the wire, and then you'll have to start your coil from the beginning. That's why I made sure I left a good amount here on the edge. So, in case I messed up, I didn't have to restart my whole coil again. Oh, see, I just ripped the wire again. Again, just lightly pull the enamel coating off. Let's see here. Almost done on this one. Again, you want to use the right amount of pressure, but not too much pressure. because you do not want to rip that wire. It's very easy to rip. All right, time for the other side. Okay. I'm not even going to try to show this part to you on camera, the difference in the enamel, because the wire is so thin you won't be able to see it, I don't think. But just know that there is like a purplish coating on here, and that it's removed to expose the copper underneath it. Okay, I think we'll finish just in time here. Awesome. The next thing you need to do is, if you have an old set of headphones or that are broken, you need to have some sort of auxiliary cable. And this just allows you to plug it in so you could listen to music on your either headphone or your speaker. So I just took this wire, I cut it on the end to expose the two copper wires here. And then you're just going to attach one wire to one wire from your speaker, the other wire to the other side of your speaker. So like we did on Monday, you are making a loop. Okay. Now, if you want to be fancy and make this better, you could use solder to get a better connection here, especially if you're going to use this long term. You want to make sure that you solder it so the wires do not come apart and so they don't short circuit and touch each other. But for us today, right now, I'm just going to go ahead and attach them so we could test to see if our speaker works. All right. Now I grabbed an old phone here. You could use your phone if you want, whatever phone is available to you. And plug in the auxiliary cable. You can see I have no other wires here. Let me move it on screen so you see it's just that phone. So I do hear sound coming from it, but it is very low. So that when that happens, you have to try to figure out a way, okay, it's low. What can I do to troubleshoot it to make the sound quality louder? So usually it's something with the spacing of the magnet and the coil in there. Let's see. Okay, now I'm not hearing any sound here. Let me check my wires again. Thought I heard a little bit of sound coming from it. Let's see. Right, let's see what's going on here. I'm playing music, cables in. Let's see if I do this. So right here is that engineering design process that I talked about. Sometimes your design will work right away, and that's really awesome when that happens. But other times, that is not the case. So then you have to go back to the drawing board, kind of discover what's going on here. I'm not hearing any sound. My coil looks good, the magnet looks good. I'm wondering if it's the wire is not connected well, because there's no reason that I shouldn't hear any sound at all. So maybe the coating isn't off here all the way. Let me try to take the coating off some more. I know I have 3 minutes until my live stream is going to be over, but I am actually going to stay on a little bit longer. And if you want to hang out with me, you're more than welcome to. But I am planning on getting this to work before I'm done today. So I might be live streaming for quite some time, but we'll find out what happens. Let's see. Gotta make sure you have really good connections everywhere. Okay, I think that one looks good. Let's see if I am right. I appreciate that. Oh, I am right. It is something with the connection. Some of you out there, if you could hear the music, please let me know. I'll be quiet for a second. Is anybody out there able to hear it? Because it is playing. Awesome. Can you actually tell what song it is? What kind of music? Awesome, thank you. I know, right at the last moment. I like being very climatic, so we wait till the last minute to get all my projects to work. Just keep that in mind moving forward. We're going up to the deadline on everything. So again, the music is playing. There are ways that you can make it louder. Again, the materials are going to make the huge difference on the way it's going to vibrate the air and make the sound amplified. The magnetic field, the amount of windings you have on your coil, all of that is going to be the determining factor in the quality and sound production from your speaker, whether it's going to be able to put out high frequencies and low frequency music. But again, here's a speaker that I made in, I think, less than 30 minutes, and it's working. So again, please check out the 2-Bit Circuits Foundation website for more projects, free projects in our playbook that you can find on the website. Lesson plans if you're a teacher, you're a stay-at-home parent, and you're kind of looking for ideas on ways to teach your students right now. These are some of them. Anyways, everyone have a great day, and we'll be back here tomorrow with another live stream of our warehouse. Take care, everyone.